In this video, I'm going to explain a bit about hardware virtualization and the various BIOS settings that can disable it. Now, laptop manufacturers in particular disable hardware virtualization in the machine's BIOS, so enabling it can really speed up the emulators and will allow Hacksum to run on Windows. So why is this important? Well, the Android virtual devices or emulators that you'll use to test your apps are on virtual machines. So what that means is that a program is running on your computer that behaves just like an Android device. It's not a real Android device and it doesn't have the hardware that an Android device has. Instead, it's all emulated in software. So virtual machines. Firstly, the cloud is built on virtualization. Modern hardware allows virtual machines to run on PCs and laptops. They can run different operating systems on a single computer. And virtual machines use the host computer's hardware. Virtualization technology has really taken off in the past few years. In fact, the cloud is largely built on it. One advantage is when you need a new web server to meet demand, for example. Using traditional hardware, you'd have to install the operating system and all the software that it needs. You'd also have to run network cables to connect it to the network, make sure there are enough power sockets nearby, and loads of other stuff. By running a powerful computer that hosts virtual servers, you can start a new server up from an image really quickly. When demand drops again, you can just shut down and delete the virtual machine. Now, virtual machines aren't actually new. IBM had them in the 1960s, but now that we have far more powerful hardware, virtualization has really taken off. Another advantage of virtualization is that you can run different operating systems on the same computer at the same time. Now, this is extremely useful as a developer because you can make sure your program behaves correctly on different operating systems without having to actually have loads of different computers. You still do need a license for each operating system that you want to run in a VM, of course, though. So as well as my Mac, I actually have a license for Windows, and I can start up a virtual machine running the Windows operating system right here on my Mac. So here I am actually running Windows 10 on my Mac. So you can see in the background that I've got my Mac, but in the foreground here, in this window, I've actually got a Windows virtual machine running. So for me, OS X on my machine is the host operating system with Windows running as a guest. So it's important to remember that there's only a single set of hardware here. So the Windows guest is using the same processor or processors on a multiprocessor machine as OS X. So doing this on a desktop computer 10 or 15 years ago was possible, but was a lot slower than it is on average desktops these days. Even so, running two operating systems like this one does slow things down a little bit. More importantly, memory can become an issue. The machine, the hardware, still has only got the same amount of RAM, so there has to be enough RAM installed for both operating systems to have access to what they need. The 64-bit version of Windows 8 or 10 requires 2 GB of memory to run minimum, and that's just the operating system requirements. So running, say, a Windows 10 VM is going to need at least 2 GB of your computer's memory. So on a machine with only 4 GB, you can see that things can and will get a little bit tight. And just to show that this is working, I can actually just come up here and I can just open something on the Windows side of things. I can open Notepad, which is a Windows desktop app. This is a test. And so it's running quite nicely, and for all intent and purposes, it actually is a full Windows installation. It's actually just running the computer. And I can go down here to About, and you can see that I've got Windows 10 Professional Edition here. I've got 8 GB of RAM allocated to this virtual machine, and I'm running a 64-bit edition of Windows 10. The other thing I can do just very quickly, I won't save that change, is I can even put this into full screen mode. So I'm going to do that briefly and then we'll swap out of it again, just so you can see what actually happens. So I can come up here to the software that is running this virtualization software called Parallels on my Mac, and I can change this to full screen. So let's just go have a go and look at that. And you can see that it took a moment to adjust, but now I'm actually running at full screen. And again, I've got the same options I had before, but I can still move my mouse up to the top here and still get access to the Mac menu, and I can come back here and click on Exit Full Screen. And finally, one other thing I can do, which is where VMs are starting to blend in with other operating systems, I can open my Notepad again, and I can come up here to Parallels I click on View, and this time I'm going to go into Enter Coherence mode. And I'll click on Yes to that. And Coherence mode actually sort of merges the two operating systems in terms of the interface at least. And what I can then do is over here, I've got my Windows application, I've got my window, this is a test, and I'm actually running it. It appears that I'm running it on the Mac, and it's not actually in a separate window. And I can actually come over here, get access to the Windows Start menu, like so, and I can run different apps, whatever I want to do there. I could run File Explorer, and there's my File Explorer, and these are windows that can be dragged around. So you're really getting the best of both worlds, where the two operating systems, even though Windows is running as a separate virtual machine, it enables me to sort of merge them, and I don't have to have one separate window like I did when I went back to this mode. So I'll just get out of that mode to go back to the original mode that I was in before we started. So that's what it looks like in a window. Alright, so that's virtualization running on a Mac. So where does hardware virtualization come in? So modern Intel and AMD CPUs have additional support for virtualization. Now, virtualization extensions on Intel CPUs are called VT-X or VTX. On AMD CPUs, it's called AMD-V. Now, VTX may be disabled in the BIOS. AMD-V is always enabled. Additional virtualization support may be provided by settings such as VTD, GVT-TS, and IOMMU. So enable these settings if you find them in your BIOS, but make a note of everything you change just in case you need to put it back. Now, hardware virtualization on x86 processors use additional instructions called virtualization extensions that are built into the CPU. Now, CPUs with these extensions can run guest operating systems much more efficiently because support for the VM is available in hardware rather than having to be emulated in software. And there is a wealth of information available with these various acronyms, things like we talked about on the previous page, VTX, VTD, etc. Basically though, when you're going to look at your BIOS, if it starts with VT- or AMD- in your BIOS, then enable it. Make a careful note though of everything you change, and if you get any problems, then you can turn it all off again and re-enable one thing at a time until you identify the one that caused the problems. AMD-V can't be disabled in the BIOS, so if you have an AMD processor that supports virtualization, then it will already be enabled. Having said that, there are other supporting technologies such as IOMMU or AMD-VI that are worth checking and enabling if they are disabled, even with an AMD CPU. So enough of the theory. The practical implications of this are that you may have a machine that supports hardware virtualization, but it may be disabled in your BIOS. Now, if Android Studio successfully installed Haxum on a Windows or Mac computer, then everything's set up fine and you don't need to do anything else. But if you've got an error installing Haxum, then the rest of this video should help you to get it working, providing your computer does support hardware virtualization, of course. Now, I'm going to start with a note here for Mac users, and if you have a Mac, then virtualization should be enabled if the hardware supports it, and all recent Macs, as far as I am aware, do fully support it, and I've never had a problem getting Haxum to run on a variety of Macs that I've owned over a period of years. So long as you've got an Intel CPU, which as of the date of this recording, all Macs created in probably the last 7 or 8 years are Intel only, you're good to go and you should find that you've had no problem. But if for some reason you've got some issue and you think VTX should be available but it isn't, then you possibly may not have applied the latest firmware updates. Check out this page, and the link will be available in the resources section, so you don't need to sort of write it down. So have a look on there on that page if there's any information you need to know if you're not getting the results you think you should be getting on a Mac. But if you're running Windows or Linux and VTX or AMD's equivalent, AMD-V, isn't available, then the first thing you should do is check that your hardware does actually support it. So searching online for your computer model and the text "Enable Hardware Virtualization" should provide the information you need. Now, for non-standard or self-built computers, check the manual for your motherboard or search online for your motherboard, possibly including the the model number of the motherboard as well, which would be quite handy and help you to find it, and also append the words "Enable Hardware Virtualization." Now, if you have a system that should support virtualization, then reboot the computer and press the relevant key to get into your BIOS. On many Windows systems, this is the delete button or F2, but your manual should tell you somewhere how to do this. Now, if you don't press the appropriate key in time, the computer will actually boot into your operating system, so you'll have to reboot and try again. Some systems may require you to power off rather than restart, so bear that in mind if you're struggling. Now, it's not possible to run software to record the screen when you're in BIOS settings, but even if I could, I'd have to swing over to a Windows machine and show you that machine's BIOS, which may still be completely different to yours. So if you have a manual for your motherboard, then you'll find all the information you need in there. Otherwise, just make a note of your BIOS details and reboot so you can search online for a manual. Word of caution here though, be very, very careful what you change. If you don't know what something does, then leave it alone, as it could actually damage your hardware if you make changes to clock settings, etc. Overclocking, for example, requires care, so don't be tempted to play around with those settings unless you really know what you're doing. And the other thing to keep in mind is you can always exit from the BIOS settings without saving if you inadvertently change something. Also make a note of every setting that you do change, including what menu it's on, so that you can undo the change if you start getting problems afterwards. This is one of those times where there's no digital substitute for a pen and a piece of paper. Enabling hardware virtualization shouldn't cause any problems, but as there's so many different systems available, I can't really tell you exactly what to change, so it's really best to play safe and keep a record of everything. And what I'm going to do is just put a couple of links on the screen here now. And all these links will be available in the resources section. This is just giving you an idea of what some of the BIOSes may look like. You can see there's an option on there. That's for an award BIOS, but for the Levano, and you'll be able to check these as I mentioned at a later time. That looks a little bit different as you can see that menu, but this is sort of what the BIOS is looking like on various computers. The Phoenix BIOS, they're just created by different manufacturers, but essentially do the same thing. BIOS stands for Basic Input Output System, in case you're wondering. That's the Phoenix, and the AMD version of the EUFI BIOS. That's that one there. You can see that's a more modern version. And we've got an AMD equivalent as well. And noting the Intel virtualization, so we're enabling the Intel virtualization on there, and then looking at some of the other options. You can't probably see that too well, but there's an option there for Virtualization Technology to enable Intel Virtual Technology, so we would enable that, and Virtualization Technology enabled. So you're looking for something along those lines. So the last one, VTD, which was actually on an AMD BIOS. So once you've enabled VTX and other settings such as AMD, VI, IOMMU, etc., you should find after you do that and reboot back into Windows that you should be able to install Haxum on that machine, and your Linux machine will also run the emulators much faster. Keep in mind that Haxum isn't needed on Linux because KVM automatically uses hardware virtualization if it's available. And finally, if you can't get emulators running or they're running so slowly that you're getting frustrated, remember that you can always use a physical Android device to test your programs. Now obviously you'll only be able to test on the version of Android that your device is running, but for doing this course a physical device is fine and you can manage without running an emulator. That might actually be a better solution if your computer has only got about 4 gigabytes of RAM, because you'll have that issue of Android, the image needing RAM, and by the time you're loading Android Studio, Java, etc., you're going to be running out of memory. So do consider doing that, particularly these days with Android devices being available so cheaply that it might actually be a better option to just grab an Android physical device rather than messing around with an emulator if you're having lots of problems with that. Alright, so I'm going to finish this video here now. I'll see you in the next video.